Next Monday, we review for the final, and then a week from today is the final. So it's real important that you get today's lesson down, and it's all about logarithms. Now, today's lesson isn't going to let you use your calculator, but I want you to go look on your calculator and see if you can find a key called LOG or another key called LN.
Would those be the same thing?
What about
No.
log base?
No.
Log N is called the natural log, and LOG is called just the log. They are a little bit different, and
Yeah,
they'll
log
explain
don't
that.
see log N.
Huh?
Log base.
Yes, but now I'm gonna explain that. Okay. What I'm teaching you today, you're not going to be using those keys, because those keys are only for what we call a log of base 10. And what I'm going to be doing with you is any base but 10. So what we're going to do is learn how to play with logs today, but that 151 is going to take you into the next level with your computer and teach you how to use your calculator to solve different log problems than what I'm going to give you today. So, put the calculators away, you're not going to need them right now. So, I need you to pay attention really carefully again like you did last Monday. Was the homework easy?
Yes.
Okay, if it wasn't, I didn't hear from a lot of you, so I'm assuming that you did well on the homework. All right, now I need you to look up here. Just watch for a minute and see if you remember. Do you guys remember how to solve this problem? Raise your hand if you do. Don't say how, just raise your hand if you remember. It's a good thing you're here today, because the reason why you forgot is because of logs.
Sounds really.
How do we solve it, somebody?
Square root. Cube. Are you factoring?
Cube root, right?
Cube root.
So to solve this, I would take the cube root of both sides. Do you guys remember that? Yes?
Yes.
Okay? And then when you take the cube root of 8, you get x is 2, because 2 to the 3rd power is 8. Does that make sense? We can solve that problem. Now stay with me. This is today's problem. Remember, this week we're starting new kinds of problem where the variable isn't the base, the variable is in the exponent. That's weird. So I haven't taught you how to use this on your calculator or work, other than your job is to get like bases on both sides so that you can put the exponents equal to each other. That's what we did last night for homework. That's what you're doing on your quiz for today. Do you remember? But can I change the number 8 to get a base of 3?
Probably not easily.
No.
Well, 3 to the 1 is 3. 3 to the 2 is what?
9.
9. I skipped 8. You're going, well, why didn't you give me this problem last night? Because you couldn't have solved it last night. I need you to learn how to get into logs now. That's the only way we can solve this problem. This one you would say not possible or I can't do. Now, let me show you last night's. Last night's looked like this, or it could be even your quiz for today, I don't know. Where I said solve, and your job was to get this bigger number into a base of 2. And what I emailed to the people that asked for help is, remember, we got to get like bases and then we compare the exponents. Solve the exponent, right? Okay, this one we can't do that. Now math can be solved, so there's got to be another system on how to help that to solve. And the system's called logarithms. Now listen carefully. If I ask you, what's the opposite of adding, what would you say? Subtract. What's the opposite of multiply? Divide. What's the opposite of squaring?
Radicalizing?
What's the opposite of squaring or cubing? Square rooting or square cubing, right? That's all of the answers when my base is the x. Now I'm going to ask you, what's the opposite of an exponent of x? What's the opposite operation of that? When the exponent is on top and it's not the base. The answer is logarithms. It's a whole new operation that you don't play with when you're in grade school. You don't play with usually in junior high unless you're in an advanced math class. So this might be new to some of you, and some of you it just might, be a, oh, I remember this now. All right. When I started teaching this, I hadn't had it since I was in college, and it was a few years before I started teaching a high school Algebra 2 class. And so I sort of forgot, and I thought, how do I read this problem? Now, girls, you're going to listen to the boys. Boys, read to me this problem right here. Ready? 1, 2, 3, go.
I wouldn't try.
Okay, you're not going to try, right? Okay, girls, show them what they missed. Girls, try. Good
Come
luck.
on, ladies.
Come on, girls. Girl power. Come on.
There you go.
All right, so the bottom line is, I forgot how to read it too. So you know what I did? I went and Googled and I said, how do we read this? The 5 isn't sitting right next to the word log, so the boys, when they gave me a gallant effort, they said log 5, 125, and they were reading it like it was all on one line.
To the power of, right?
That's not correct. So now you've got to learn how to read this, and that's what we're going to do right now. How do you read this guy right here, all together?
10 to the power of x equals 100.
10 to the power of x
The 5 was a
equals 100.
subscript, wasn't
Did
it?
you all, that was easy, right? Now you got to remember how to read log problems. And the log problems, I'm going to go back here again, and where's my log problem? Here. This log problem is read as log, you ready? Base 5 of 125 equals 3. You might want to write that down if you didn't know how to read this problem. We start out by saying log,
base of 5.
then my brain and my mouth has to name the base, and that's always the little number. And then my brain has to say of the big number, and then equals whatever's at the back end.
Oh, base 5.
Okay, so let's all read what's in the blue box. Try it again. 1, 2, 3, go.
Log base 5 of 125 equals 3.
Okay, now you're reading the problem correctly. Read this to me, the red box.
5 to the power of 3 equals 125.
Do you see how your mouse said power of 3? You didn't see 5, 3, even though you saw a 5 and a 3. See, you've been trained how to read exponents. Now you got to practice log, how to read a log problem.
Base 5
And
of
how many
3.
times do we have to do that before it sticks in your brain?
7 times.
At least 7 times. So we're going to be doing a lot. Don't fight me on it. It's trying to make you comfortable. That's what I did when I forgot how to read these too. It's like, okay, I kept reading it and reading it and reading it. When I say the base, that's always the little number that's a subscript down below the word log. It's not on the same line as the log, it's a little number. Okay? All right, now this is what I did with my high school students. I used to give them a piece of paper with some little Post-it notes and make them do this switch. But you guys are more mature, so I'm not going to do the little kid thing I do with my students. although some of you would have benefited from it. But what I want you to do is this. Put your two hands up in the air. And all we're doing is this. Cross over your hands, switching. So whatever's in your left hand is now going to be on the right side. Whatever is on the right side is going to be on the left side. How hard is that, right? Easy peasy. Now my little high schoolers, when I used to do this, I had to do it like 50 times with them. It was more than 7. But finally they got it. And so then I'd make them take the two pieces of paper and I'd say, okay, the yellow one is going to go here. And the purple one is gonna go over, oops, I did it wrong, there. And switch it, right? All right, so now what we're gonna do is teach you how to change a log problem into an exponential problem. What you're going to do is you're gonna always write the base down first. When you wanna go to an exponential problem, you put the base that's over here as the big number. They're both called bases in exponential and in logarithms. And now what you have to do is write an exponent. The next thing next is you've got to switch these two and put the 2 here, and then the x, the of number, goes at the end. So if I say to you, I have log base 9 of some number and it equals 2, and I say solve for x, you go, I don't know, I can't use my calculator. But I can convert it to an exponential problem. And when I convert it to an exponential problem, what's 9 squared to the second power?
81.
So x is 81. I just solved a log problem, but I used exponential to help me solve it. Okay, let's take this guy and change it to a log problem. Well, anytime I ask you to change it to a log problem, you start out with the word log. And then you want to get that little sub number first. So the sub number is your base. The sub number in a log is called the base also. Those words are it's the same thing. So that's how I remember those. So I find the base of the exponential and I make that the base of the log. Now the next part is this, watch. You gotta switch. When you go from exponential to log or log to exponential, you can't write the remaining pieces in the order that you see it. You got to switch them. So I have b to the third equals 27. So the of number is 27, and the answer is 3 to that log problem. Now, how many times do you have to do this? 7. So guess what we're going to be doing? It leaves 7. So now I want you to try taking problem number 1. It's written as a log, and I want you to try writing it as an exponent problem. Remember, the bases are always the same. So whether you're writing a log or you're writing an exponent, you want to put your base number first, either right after the word log as a sub, or if it's the exponential part, it's got to be the big number. Then you just switch those other two numbers around and then write it in that order. Okay, boys, what's my answer?
2 cubed equals 8.
Okay, how easy is that? 2 cubed equals 8. Is that true?
Mm-hmm.
Yeah. So do you see how the exponential equation and the logarithm equation are giving you the exact same information, but one is written as a log, one is written as an exponent. This one we've already studied, right? So that one's sort of easy, and you see that it is true. These are equivalent operations, but they're just written differently. It's like saying 2 plus 3 equals 5, and 5 take away 3 is 2. You're still dealing with the same 3 digits, but we're writing it in a different form. That's all we're doing. It's not hard. When you say, oh, I studied logarithms, you know, most people get intimidated and go, ooh, you must be smart. It's not smart, it's just, you don't see it at the grocery store. I'm going to show you today. In Arizona, we use it every single solitary day, starting like right now, today.
So we can do.
All right, I give you an exponent. Now write it as a log. Go. Would you pick one ahead? Girls, read to me what you wrote. Girls. I'll help you. I'm a girl. Log what?
Base of,
Base what?
Well, let the ladies have it now.
3 of what? 81
What?
equals 4. This isn't hard, guys. It's just, again, the base of the log and the base of the exponent are always exactly the same thing. And then you've got to switch the exponent and the answer around when you write it in the other form. It's sort of like saying 2 plus 3 equals 5. And then when I do a subtract problem, I do 5, and then I switch, right? And first a minus 3 equals 2, so I switch the digits. You're doing the same thing. So don't feel intimidated by this. It's really quite easy, but it takes practice. Okay, boys, I want you to read to me number 3.
Log base 4 of 4 equals 1.
Okay, you've got your 3 done. What happened to this side? Sad, 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 sad. Okay, boys, on this side, read problem number 3.
Log base 4 of 4 equals
Okay, you got your 3 in. Okay, Alex, read this one.
Log base 4 of 64 equals 3.
Perfect. Girls, you take the hard one. Girls, go.
Log base 7 squared.
Of what? Of square root of
This is square.
7 equals a half. You just read what your eyeball sees, but you gotta call this a base. So log base 7 of, now what does your eyeball see? Square root 7 equals a half. It's not hard. I can put in anything in there. You're gonna put in sines, cosines, tangents, cotangents. You're gonna get all kinds of new words. But I can put in anything in there as long as I learn how to read it properly, and that's my job in this class. How do you read it? Okay, have you all done the third one here because you guys are A students and you're ahead of me? Okay, what do we get? 4 to the 1 equals 4, easy peasy. And over here, what do we get? Log what? Read it.
1. Log base 5 of 1 over 125 equals -3.
Yep. You gotta practice this, otherwise when you go home and you don't touch this for 4 days, your brain's gonna go back to 0 again. You gotta practice this with me at least 7 times today. All right, I want the girls to take problem A and C and the boys to take B, and I want you to write it as exponents. Go. Girls take A and C, boys take B, and I want you to write it as exponents. Did you see how I was nice to you guys and I even wrote it out for you here? Because I forget, if I don't teach this course for a year, it's like, oh man, how do you read these again? And I just look at my notes and say, okay, I got it, you know, practice it a few times. those of you that came in real early, I was practicing.
Hmm.
Because it's not something that you, again, you do in first grade, second grade, third grade. This is more higher up stuff and you don't use it as often, so you gotta practice it. Okay, boys, read to me your answer.
7.
Seven's power
To
of
the
half
power of
equals
half.
square root of 7.
7
To the
to
power
the
of a
power
half.
Yes.
I was wondering if we
equals
could say that.
radical 7, isn't that true?
Absolutely.
We studied that.
Mhm.
We went over that fractional exponents really means it's the index of your radical. We already did that. Oh. Can I do this on my calculator now?
Mhm.
I can do radical 7 on my calculator. I can't do this on my calculator. That's why you gotta learn how to be able to switch these guys around. Put it in exponent form, put the exponent form back in logarithm. Don't tell me that there's a way to solve it, because I know. That's not my class.
Why do calculators only use base 10?
Because if you didn't, how big would your calculator be?
Mm.
You'd have more keys than you could fit in this room. But there is a way to use your calculator on these problems. I'm not going to teach it to you because otherwise you'll do that instead of my work. Ha. Right?
Yeah, I know.
All right. So, 151 is going to teach you how to use your base 10 even though the base isn't a 10. All right. Girls, read to me your answer to A. That's this side of the room, guys, in case you haven't noticed it. So, girls, go.
14 over 3 equals 64.
How many girls do I have on this side, boys? I only heard one. Come on, guys, the more you walk it, talk it, eat it, smoke it, drink it, the more you're gonna learn it. So when I ask you to do it, you gotta do it for me, otherwise I gotta have you up on the board, and I don't wanna do that yet. Okay, girls, let's do C, go ahead. All together, girls. 6,
Power of negative 2 equals 136.
okay, is that true?
Was that just 7? Cause I just got it. I mean, like, more solidly. Have we done this 7 times now?
No,
No, okay.
only the girls have done 7, you guys have done 6.
I'm not trying to be impatient, I just lost count.
I know. All right, so we're gonna try it some more. I'm gonna give you 2 minutes, starting now, and I want you to write each exponential equation as a logarithm equation with your partner.
Mm.
Okay. With your partner. Can you
My
guys
partner's
get
at
your
work,
partner?
by the way, she just got a job,
So
so I'm not zero.
He likes the
What?
cloud share.
My spouse got a job.
So if you want- Well, Angel here has to
I was just joking, she said do it with your partner, I'm like, my partner's partner.
Okay.
Okay, starting with
How
A.
you feel about it?
Road. Come on over here.
We're doing this.
You're doing that whole slide,
Alright,
yes.
these arrows are confusing me a little bit. Okay, multiple choice. Should we just write it in here with how, the other version of it?
Yep, write it
Oh,
as a
okay.
log.
Yeah.
All of these, we
Okay,
want you
log.
to start out with the word log. Just do A through C,
Zero.
don't do D and E. Unless you're bold and brave enough.
Logo. 0, 1 equals 8, right?
I believe so.
Read it properly, log
No,
of.
8, 1 equals 0.
That's what it's, wait,
This is-
I'm looking at where it says 8, 0 equals 1.
Oh, I'm here, I'm on this side, right? Are you
What?
on
Yeah.
this? Okay, yeah. So when you read it out loud, you should be starting with log base of equals,
Log 0? I was getting log 0. Okay, I'll check out B. Oh, stupid correction. What the heck, these are the harder ones.
did you lose your partner or you already did it?
Oh,
Did you?
I did.
Okay, go with these guys.
Log 1, third,
Base.
What's confusing him is see how you have your log and your base on the same line? And all I'm using is these words to help you. Start over here with the word log.
okay.
And what he's getting confused on is that your log and the base is on an equal line. And then it looks like you're floating the of number and the equals as an exponent.
Right.
So you gotta be careful. I would take that off the point on that.
Okay.
Can you tell me if I wrote B, for example, correctly?
B,
Yeah, because I'm sort of gaslighting myself out of
log,
into backwardsness.
base 6. You should have a base 6.
Base 6 for B.
Look.
Log base 6 for B equals
There's-
3 to
watch,
the radical.
there's a
I
hint.
understand.
Do you
I
see
see what I
how-
got backwards.
You see I got 8 and 6 and 1/4 all in red, and then I say your base is in red. So I'm trying to tell you that when you start writing your log problem, this big base has to be your sub number. And it's gotta be below the line. It can't be equal with the word log or I'm gonna take off points. Okay, there's no talking, so are we okay with those 3?
You said with your partner.
Okay, girls, show the boys your stuff. Read number C, the long part to me. Ready? 1, 2, 3, go girls.
Blah, blah, blah.
That wasn't too bad. I heard lots of voices. They weren't together, but, all right. Okay,
Sounded like a
boys,
cafeteria.
boys, all together, read B log.
Log base of 6 cube 6 equals 1/3.
Cube root
Cube root
of
of
6
6 equals 1/3.
equals
How many
1/3.
inches is this one?
All right.
Oh, shit.
Now, you gotta listen. These are called baby problems, easy problems, because you're putting your base and then you switch the exponent and the answer around to write it as a log. Easy peasy. What kind of problems am I going to give you? Look like these two. Why? Because they're harder. Why are they harder? Because I have more numbers here. Before you can write a log problem, you gotta have the exponential part by itself.
Yeah, that 7's gonna
So what do I have to do to get rid of a positive 7 on one side?
take it away from both.
Take it away from both. Remember, we do the same thing on both sides? And when you take it away from both, we get 2 of x equals 18. Now, last night, you couldn't have done this problem. Because I can't write 18 as a power of 2. 2 to something. 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32. So I skipped 18. This is not going to be solvable by the method I gave you yesterday to solve, where your bases have to be the same. So what we're going to have to do is learn how to play with logs, because in the next class they'll show you how to use the logs on your calculator and be able to do this problem. All right, for my class, you just have to get it into the log problem. That's my objective for you guys in 97. So, write this as a log problem now. Make sure the base is in the lower part after the word log, and make sure you switch the exponent and the answer, just switch those two numbers around when you write it as a log. Easy peasy. Now, if you pick up your calculator and let's say you don't know how to use logs on your calculator and you use that log key and type this stuff in, you're gonna get the wrong answer. Your calculator can still not do this problem. It can, but you gotta know how to do keystroking on your machine, and that's the next guy's job, not my job. Okay? All right, let's look at a log problem and see how can I change it to an exponential problem. And again, your first job is to isolate the log piece. That means the base and the of number. So what do I have to do with that plus 2?
Subtract.
Subtract 2, like we did the very first day of class.
Okay.
And now I have the log piece isolated equal to the number, write it as an exponent, and guess what? You're going to be able to solve this problem. If you really say these log things and practice the conversions, you're going to go home, and if you don't wait till Sunday night to do your homework, you're going to do the homework and you go, no, this is pretty easy, because you're going to get used to that switching it around and how to write it in the other form. And it's going to be an easy kind of an assignment if you practice. Okay, 3 to the 4th equals x minus 7. Now, can I solve that problem?
X equals
Yeah, I can do 3 to the 4th on my calculator, get 81. And now I can add 7 and divide by, or add 7 and I got the answer, you're done. So we have a very complicated log problem that I can change to a very easy,
X equal
first day
88.
of class math problem.
So question, if it looks like that, we have to check if you can further,
Mhm.
simplify.
If you're gonna write it as an exponent from a log, you gotta have just the log piece by itself. That means the base and the of number. If it's being added, subtracted, this is as hard as you're gonna get in my class.
Oh, no, I mean, the actual
Solve.
answer down there?
Oh. The actual answer down there is what, 81
Eighty-
plus 7
it's
is
88,
88?
right?
88. But
Yeah.
we have to look for that, or can we leave it like that?
Oh, they want you to write it as an exponent, so, or write it as a log, or write it as an exponent. The directions say write it as an exponent, so you leave it that way.
Okay.
Good question.
Oh,
Cool.
Don't,
come on.
I'm gonna get to solve in just a minute. You're just ahead of me. All right. Now, when you are done with these 6 problems, I want you to stand up. I want you to write each of these 6 problems as a log. You guys are a piece of you know what. Look at these guys. Getting ahead.
No way.
They're not even listening to my story.
The Ramones all got it?
Yeah, look at my back row. Front row.
You guys look like a band, that's all.
You look like a band. Now compare
Why
with
didn't I
your
get to join?
stand-up people, if you got the same answer on your paper.
If she was next to me, I just had to stand next to her because you can't be the original. Here I am.
What's the shortcut for these 6 problems?
Just look on the right-hand side.
Look on the right side for the what?
Base.
The base.
Yeah, that's it. Almost perfect.
Because all you gotta do is have a thing that works. Okay, all you gotta do, if you have a base of 8, you gotta come over here and look for the one that has a base of 8. Bam, you got it as a log. But see, what I was trying to have you do on this sheet of paper where I showed you all the ones on the right, guys, what I showed you on the right is that I was looking to see if I just have a base of an 8 here, I gotta go through my logs. Oh, there's the base of 8. Here's the base of 1/3. Where's my base of 1/3? Oh, there it is. You see how fast it is? But you gotta get used to looking at the base of the exponent and the base of the log. Now, how hard was that? Pretty easy, right? All right, so now let's go to the next step, or the next slide. The directions now are not change this to an exponential problem or change this to a log problem. Your homework's going to start out that way. But then all of a sudden, the directions are going to say, now solve this puppy. And when it says solve, yeah, you could go look at my answers I give you in the back. That would be easy. But again, what I'm looking for is to see if you've changed this log problem to an exponential problem. Because you can't solve this with your calculator. You can't solve this one with your brain unless you got the answers in the back. You gotta show what's called work. And the work is when I give you a log problem, you gotta change to an exponential problem first. Go ahead, do it. If you don't know how, cheat and look at your neighbor and ask them. You cannot solve this with your calculator. If I give you this problem on an exam, you're in big, big, big doo-doo, to put it very nicely, because unless you know how to change this to an exponential equation, you won't be able to solve it. So the first step you should have on your paper is x to the 4th equals 81. Can we all do that? Okay, now you gotta remember, oh, how do I solve a math problem when my base is back down to is a variable, and I've got an exponent of 4, how do I solve that problem?
Find the square root.
Can't be square, it's
Give
gotta
it
be,
exponents equal.
huh?
Exponents equal on both sides.
Oh, you could, no, you can't, cause there's an x, no, good.
Fourth root.
It's gonna be the
Yeah.
4th power. yeah.
You gotta take 4th root to both sides. So we gotta do this, radical 4 and a radical 4. Remember when we have an index and an exponent underneath the radical, it just comes out as an x. Remember that last week? Okay, and now I gotta do the 4th root of 81. Now you can pick up your calculator, or you can look at your little half yellow sheet and look and see if you can find your 81, and what's the 4th root of 81? 3. That's the answer I had down here.
You're net.
Or you could sit and write it like this, and your and your base is a 3. Is that what you were saying?
That's what
Oh,
Okay, yeah. Okay, try the next one. Show me work. It's written as a log problem. Can't use the calculator, so write it as an exponent problem and see if you understand how to do the work. What's my exponent problem?
10 to the negative 2
Equals,
is x.
goes X. That's all you gotta do. See if you can convert one to the other. Usually the other one is gonna be an easy computation problem. Use your calculator or use your brain. You know when you have a negative exponent, you flip it upside down and then do 10 to the 2 as your base. Easy peasy. Okay, try the next one. What happens if it's written backwards? Is there any difference to your exponential one? Nope. Try it. You guys in the back done already?
No, I'm just
Okay. Okay, your first step should be what? Writing it in exponential form. Y to the 5 to the y equals 125. Now you can't do the y root on both sides, so now your brain has to click and say, okay, I better be able to change the right-hand side to have the same base. Because that's the only way you know how to solve exponents, is that I have a base of 5 here. I gotta go on my little half sheet and find 125 and see if it's got a base of a 5. Does it? 5 to the third. So this time, our work is gonna have like bases, these little like bases. And then remember I told you yesterday or Monday, put a line. Now you take your exponents and put your exponents equal to each other. Y equals 3. That's called work. Again, if you hand in your homework, remember we're on our last 2 assignments now. If you hand in your homework with just answers, it's a 0. You gotta show me this conversion back and forth. Not for me being mean and nasty, it's because I'm trying to sit there and have it stick in your brain more than 5 minutes. Okay, try the last one. If you thought last night's homework was easy, tonight's homework is going to be pretty easy because you're doing the same thing. They're going to give you a number here that will be able to be converted to the like basis. Because in my class, that's the only way you know how to solve these exponential equations with the variable as an exponent. So what is 81 as a base of 3? Look on your half sheet or look in your calculator, what do you get?
3 to the 4th power.
3 to the 4th power. So I should see that work on your paper. If I don't see this on your homework, then I'm gonna mark it down. Easy peasy? Yes? Okay. Solve all 4. Work with your partner. What did you write for your first step? Again, I gotta do this 7 times for it to stick in your little brain. We can go up to the board if you wanna go up to the board, or you work with your partners. What did you write for the first step? Don't copy, you wanna ask, why did you write that? How did you get that? Nobody but one group is talking.
No. No.
fast. I need to go back to when I understood.
Mhm.
So Ms. Barber, I have a question. In the meeting, the steps that I'm doing with these fractions, do I necessarily have to like show you like manually how I'm doing them, or can I just type them into the calculator?
Show me. Which one? Okay, go. Now you subtract 5, or are you doing it? Or are you doing it? Get rid of your, get a GCF and get rid of that fraction.
Okay.
Okay.
I'm stuck on this one too. I'm stuck on that one.
You feel solid right now?
What?
You feel solid?
Yeah, I'm okay.
Okay. Then, can I compare your answer for B? See if you agree. I know I have them on different sides. Okay, cool.
I see what you did.
I multiplied each side by 9.
GCF. Okay, gotcha. That makes total sense.
For C is.
Just in case I didn't have a calculator at home. Makes total sense.
5 to the 125, is it actually that? No, you're saying it's 5 to the y. That's a different C.
Total sense.
Oh, I'm still.
And how hard is 9 times 2, and 9 times 5, and 9 times 1, 9? Again, if you know how to solve these, every one of these, when the variable is in a different spot, you gotta use a different strategy from either exam 1, exam 2, exam 3. It's getting your brain used to playing with all these different topics. Now, don't copy. What you need to do is ask. How did you know to do step 1? How did you know how to do step 2? Ask questions. Yeah.
I have a question. What made you put the plus or minus?
Oh, remember when you have an even radical, 2, 4, 6, 8, your number inside could be negative or positive. We did this plus minus, remember? Like, this was the problems we did in class where I said x squared equals, let's say, 36. And I'm saying to you, what number times itself gives you 36? You'd say, well, it's 6. And I'd say, well, is it -6 times -6 equal to 36 also?
Gotcha.
Yeah. So what we learned how to do way back when is on this side, we put square root. On the side that has the constant, you gotta put a plus
Oh,
sign.
no. Crap.
No crap.
Alright, that makes sense. Thank you.
It's basically what we did for the but we're just in that extra step to get this out of that.
Look, guys, when you come up with something like this and you go, holy bleep bleep, when that variable goes to the top, you know, when you have a variable as an exponent, you gotta go back to Monday's class and say, okay, I gotta have the same number on both sides as a base.
Don't have the same thing.
And that's where, once you get the same number on both sides as the base, then you play with just your exponents.
What about that the exponent in that parentheses won't matter because the base is the same, or does that exponent in the parentheses still matter? Or on D.
Which problem are you looking at?
D.
Oh, D. Now I ask you.
So you see where you have 6 squared in parentheses to the
That's
power of x?
6 to the 2 to the power of x.
Yes.
Remember when you have one
I don't
base
remember what I-
and 2 exponents, we multiply those together. That was your 8 rules of exponents we went over in section 2.
Okay,
And I
so
know it's a
2x
lot.
equals a quarter now,
2x equals 1/4.
at that
yes.
point.
So here's 2x equals 1/4. You can do a GCF if you want, and do a GCF equals 4. Multiply each side by 4. If you don't like working with fractions, you're gonna get an 8x equals 1, and then divide each side by 8. You shouldn't be picking up the calculator. You should be showing me every strategy we've learned on so far how to solve for x. And notice what I've highlighted there for you, the different types of problems of where the x is. If you got a highlighter with you today, I would highlight that x so that when you go and do your math problem and you don't come up with the answer in the back, you can go back and say, where is Mr. X? When I give you a log problem to solve, you know, we're solving each of them differently when that x is in different spots. Some of them we're doing square roots, some of them we're getting like bases, some of them we're solving like the first day of class, some of them we're using your 8 rules of exponents. All right, yes, yes. Oh. Oh.
The explanation on
D, D, okay. When the x is the answer to your log, that's when you're gonna have to get like bases, and they're gonna give you problems that will let you convert them to have like bases, because otherwise you don't know how to solve them. You can't solve them. Are you okay? All right, go to the next slide. You're gonna have some instructors that will tell you, you've gotta memorize those 3 properties of logs. I don't. Watch, listen carefully. Just listen carefully. Do you see how if the base and the of number is exactly the same, what's your answer always going to be? Whatever the exponent is on the of number. Don't have to show me a stick of work. Nice. When the base and the of number are exactly the same, and you have an exponent of a 1, or you don't see an exponent, what's always the answer to your log problem? You don't need a calculator. When the base number is a variable and the of number is a 1, your answer is always 0. Memorize that. I'm all confused. I don't memorize it. If you gave me those 3 math problems and said, what's the answer? I would change them all to exponential problems, and then it's real easy for me. Let me show you how. When the base number and the of number are exactly the same, what's the answer going to be? Well, if you have this chart here, the base number and the of number, that's this guy right here. What's my answer going to be? 1. I don't have to see any work. Don't have to see you convert it, but you got to memorize that. Now watch. I don't memorize those rules. I just put in X here. And then I'm going to write this as an exponential problem. Takes me 5 seconds, more than thinking about those rules. How do I write this as an exponential problem?
12 to the root of x squared.
12 to the
Or
x equals
12.
12 to the 1. What does x equal? I just proved to you why that rule works. The green rule. Now I have log 4 to the 1 equals, I'm going, I can't remember what that one is. I don't remember. So again, I put in x here, now write it as a exponential equation. What do you get? 4 to the x equals 1. What does x have to be in order for the whole thing to equal 1? 0. Your exponent always has to be 0 in order to have it equal 1. We did that towards the end too. Now, all I'm going to tell you is that you can memorize those 3 and then recognize it. You see how I color-coded it? Or you just always remember how to switch a log to an exponent, and then I think it's an easy problem. So here's this one. And what do we have? Logs base 4 of 64 equals something. I don't know what it equals. And they want you to convert this so that the base and the of number are exactly the same. I don't bother with that. I don't care. If it says use the special log formulas, I just go, "Nyeh." I'm not doing it. So write this, let's put an x here instead, equals x, and write this as a log problem. What do you get? 4 to the, or as an exponential problem. 4 to the x equals 64. Now 64 has a power of 4 in it.
Yes.
X equals
3 or 4?
3. Because 4 times 4 is 16, right? 16 times 4 is 64. So these 3 rules, in the olden days when I was very young in my 20s and starting to teach pre-calc class, I'd say, you gotta memorize these, you know, and that teach you this little shortcut. Write everything as an exponential equation, and it's usually a very easy problem. This one here, when the base and the of number is exactly the same, I remember that one. What's your answer? 1. But if you forget, you write radical 3, what? To the x equals radical 3. And what's the exponent up there if I don't see it? 1. It works out. But you can either memorize the rules, or you can sit there and show me it written as an exponential equation. And when it says, what's the answer, you just make that your x, so you have 3 to the x equals 1. Well, what does x have to be for that base to turn into a 1? 0. Or if you know that any log that has an of number of a 1, you don't care what the base is, it's always a 0. You memorize that, fine. If you do it 7 times, you won't need to show the word. What's this one? When the of and the base is exactly the same, and I have an exponent of a 7. The answer's 7. How'd you get that? Either you know the rule, or you say 4 to the x, because I didn't know what that was, equals 4 to the 7. What does x have to equal? I'd like bases. 7. Okay. When you have numbers added or subtracted and it says simplify, you always work on the log piece first. Don't worry about a number that's being multiplied out in front first. Clean up the log piece first. So 8 is 2 to the 3rd. Do you agree? You should know that by now. Now my of number and the log and the base is the same. So what's the answer to this whole piece?
2
Watch. When the log base 2 of 2 equals 3. When these two things are exactly the same, what's the answer to that log piece?
More.
3. Whatever you see on the base, or on the exponent. This thing right here, this is the answer to that piece. So this piece right here is a 3. Now what do we have? 10 plus 5 times 3. PEMDAS, what you did in 3rd grade, what's the answer?
25.
25. 15 plus 10.
He's broken the season.
So when you're doing, you have a whole bunch of stuff on your problem, you always work on the log piece first and get rid of that word log and simplify it however you can to get a number out of it without using your calculator. And then you multiply anything in front of it, add your 10. Okay. Each of these, can you simplify? Yes or no? Every one of these problems
Yeah.
has where I can change the of number to be the same as the base number. Do you see that? That's called a shortcut. Yes, you can put this equal to x. If it said solve, you can go 2 to the x equals 8. But if you want to be a math major, or you're going to the 151, or you're going to a calc class, when a math book gives you a base of 2 to a number, more than likely that can be written as a base of the same, or an of number of the same base. So what's the answer to that math problem? 3. 64 can be written as 8 squared, right? What's the answer to that log problem? 2. It's the exponent, not the base. Okay? What's this one written as an exponent? 3 to the third. What's the answer? 3. When the of number and the base are exactly the same, it's the exponent that's the answer. 1/16. I need it to have a base of 4. Can I change 1/16 to a base of 4?
Yes.
Well, it's a fraction, so the first thing I want to do is get rid of the fraction. Now I have 16 to the -2, or -1. And now can I change it so that it has a base of a 4 to match the base of the log?
Yes.
So this can be written as log base 4 of 4 to the 2 times -1. These cancel out, what's my answer? -2. What you gotta do is you gotta start understanding what they're asking for. And when it says simplify and they give you a log problem, either you're gonna be able to convert that log problem to one of those 3 properties where the of and the base are the same, where you have a 1 and a 0, then you know you got that property going. All right, when are we ever gonna use this stuff? You ever gonna use it? Yes or no?
Yeah.
You know I'm gonna hit you with it.
We're gonna use it on the test.
When are we ever gonna use this?
On the test.
It's for your brain, you guys. Do you know why I keep saying to you, you gotta sit and do your homework, if it's a Wednesday, you gotta do your homework before Sunday night? You know why? Because within 24 hours, you forget. Shut the door, we can go back.
Which also means you have to do it after Friday.
It means you gotta start it tonight. You gotta practice 7 times for it to get into your brain. if you go and say, gosh, I might go ahead, it's Wednesday, I don't see Barbier till next Monday, good for you, you might be happy about not seeing me, but the bottom line is, you're gonna forget most of what's taught to you on Wednesday, and you gotta spend another hour reteaching your brain. And the reason why is because of this formula, look. That's a math formula. What word do you see there? Logs.
Okay.
I've never given you this formula before because there was some very, very smart person that surveyed zillions of students and found out that most kids will retain about 88% of what came out of my mouth if you don't do a darn thing within 24 hours. 88%.
Will retain 88% if they don't listen?
No, they have to listen.
Oh, if they listen, okay.
Yeah, if you don't listen, you
Makes
retain
more
a
sense.
0. That's a good point. Yeah, don't listen, fall asleep, on your phone, whatever it is, it's 0. But if you listen and you pay attention in class, most of you will retain 88%. So it means the other 12% has gone over your head, or you just forgot it. Sort of like when somebody gives you their phone number and you forget it after they say it, or after, 5 minutes you forget it, you have to write it down or put it in your phone or whatever. That's what your brain does. So this formula says that most people will remember 88% of a lecture if they listen. But what happens is every May, and we're in May right now, how many of you are going to take a course not till September?
Just you, huh?
Who's going to take a course in the fall, math course? You're going to sign up for a math course in the fall. It means for 3 months you're not going to do math, correct? You're
Oh,
going-
practice.
Right? Well, in 3 months, you know how smart you're going to be when you walk in the fall? This formula will tell you how much of my material you're going to remember if you wait till the fall. This is why I hate spring break. Why do we do, or summer vacation? Why do we do summer vacation? Every fall I have to go back and review. When you guys walked into my class, we had winter break and we were gone a month. If I had you in a 92 and then I didn't see you till January, you were gone a month. And I knew that you weren't going to remember very much of what I taught you. And when I started this class, what did I do? I reviewed what we did in the 92. And every day I would say, we did this the first day, we did this the first day. Why do I keep doing that? Because of this formula. I want you to take out your calculators and we're going to practice doing logarithm problems with your calculator. I want you, listen carefully, type in 88 minus 15 log,
Ah,
hit the log key, and there should be a left parenthesis, right? And then we're going to type in 0 plus 1, just type in a 1 and close the parenthesis and press enter. What does it say?
88.
That's how much of the material you're going to remember within 1 day of what it's been taught to you.
That's what that formula is.
Now, T stands for months. Months. So now I want you to do the same formula, clear it, and you're going to see how much of my class you're going to remember when you go into the 151 class or the 142 class in September, 3 months later. And you're going to sit there and go, oh man, I hope that instructor reviews. Some do, some don't. That's why I say keep your notes always. So you're going to type in 88 minus 15, hit the log, and then 3 months is 3 plus 1. Hit a 4 and close parenthesis, press enter.
70.
That's
78, 79%, you're already to a C plus.
just 4, okay.
Now the college will sit there and say, people, don't wait a year to take another math class. Like you finish my class today and you go, man, I don't wanna take one, I'm gonna take a year off. Have you ever heard of somebody taking a year off?
Yeah.
Yeah, because they're just burned out and they hated
burnout.
math and blah, blah, blah. Now try this and see what happens after you wait a year to take another math class. Clear your calculator, do 88
The 9 months?
minus 15, hit the log.
Which could work out for
And
some
now you're gonna plug in a
situations.
13, because it's 1 plus how many months? So that's 13 months. Press enter.
71,
What do you get? Yeah, you're barely at a C. That's if you mastered everything when they gave it to you. So a year later, you gotta learn half the material all over again. That's why they say don't take off time. If you can take a class in the summer, well, I would take a class in the summer. It's only 5 weeks. It's 4 days a week instead of 2 days a week. But you're fresh, you know, you crank out a class in 5 weeks. I'm a 5-weeker, go for it. So, you know, I would do that, but that's just me.
If you
All
do
right,
take summer
so-
break,
What you get is about 79% after you've taken a summer break. That's why teachers review when you come back. You don't remember everything, it's bad. Now, the next story is very dear to my heart. My son used to work for the D-backs in 2012. And so we went to visit him in Phoenix, and I brought my dog with. And it was June in Phoenix. Do you guys know what it's like, June in Phoenix?
105.
It was like 115 people,
Yeah,
it was hot.
that's what I thought.
And so it was doggy day at the D-backs at Chase Field, in case any of you know that. And you get to bring your dog, and then everybody walks around the whole field with your dog, and you see all kinds of dogs, and it's just
Pavement.
fun for dog people. All right, so I brought my dog, brought my son was there.
Pavement.
We finished the whole game. The dog gets their own seat at the game. It's really cool. So my dog's sitting next to me at the park, and we're having Portillo's hot dogs and having a great time. We finally finished the game, bring him back to the car, and the car's been sitting out in the sun for about 4 hours, 5 hours, 110, 115 degrees. My husband, bless his heart, he's 5 years older than me, goes and throws the keys to the car in the back seat, and then we're lifting our old dogs into the car, and he shuts the car door. Shouldn't be a problem. But the dog was real excited, and guess what the dog did? Sat and jumped on the lock key. So now, it's 110 in my car, 110 outside. My dog's locked in the car. We're in Phoenix, we live in Tucson, we didn't bring a spare set of keys. How the heck, I'll say a nice word, do I get my dog out of this car, and how hot is it in that car when it's 110 outside? My car has been closed up for 4 hours. All of a sudden, 5 minutes later, I see my dog lay down. This is a true story. And now she's in a very, very hot car. They say all the time on the news, check your back seat for your kids, right? This is my dog, but it's like my kid. So,
use
you know what I
pressure
said to
equals
my
area over
son? I said, go to your car, get your bad word bat, and go smash my windows. He did. Now, the question is, this is my 20-some-year-old son, which window should he have hit?
Passenger rear.
Yes. What does he want to hit? The front window, right? It's like, hit the little window. Not bright kid. Hit the little one. Why? Because I thought, it's little, and then I can drive back to Tucson and get it fixed. So he did break in the little one. We got the button open, got the dog out, and the dog lived happily ever after and just died last year, so that was good. But what I learned is, when I got back to Tucson here and I had to have my window fixed, you know what the most expensive window to get replaced in your car?
It can be that corner
The
one.
little teeny one, 'cause
Yes,
it's got
because it has
something-
the whole frame attached to it, and you usually
it
don't just
curves.
replace the panel.
So the moral of the story is break the big window in the front. But, all right,
Big
so
window in the back.
this is what happens when your dog is in a car. So take your calculator, and this is an LN function. LN means natural log. It's sort of like the real log you'll learn about this next semester. But type in 13.4 and then hit the LN key. And then we're going to say 50 minutes. What's your temperature of your car going to be after 50 minutes? So type this into your calculator and press enter. Close the parenthesis after you're 50. Don't forget to close parenthesis. And how hot is my car if the temperature was 96? How much is it gonna go up?
By 40.
Goes up 41 degrees in your car just after 50 minutes. That's why when my dog laid down, I had just taught this lesson because it was in June, right after, like right now. So I said, get that bat and break my window. Because I knew that it was 110 out there. It wasn't, 96, it was 110. My dog's gonna die soon. And that's why they keep saying on the news, hey peeps, watch your kids. Make sure you don't leave them in the car even if it's for 5 minutes because it will get hot. Then the last one real quick. I love these stories that relate to why I'm teaching you what I'm teaching you. Any of you have babies yet or you're gonna have babies? When you go to the doctor, they looked at my little baby boy that was like this big and they said, oh, he's gonna be 6'5" when he grows up. I said, no, he's not. How do you know that? And he goes, we have formulas. It's this formula that will tell you how tall you're gonna be at different stages of your life. This formula just represents how tall you're going to be X years old. And you can figure out the height of your kids, because I was always amazed. It's like, how do you know my kid's gonna be 6'5"?
They
I
say
know
they
I'm
can't grow
tall.
with formula.
Huh?
And they say you can't grow well with formula.
Yeah. So
Like baby formula.
at age 10, if you put in a 10, you're at 80% of your height. So they can figure out, if you're 5 foot and that's 80%, you get, one more foot. So it'll be 6 foot when he's fully grown. Isn't that cool? This stuff isn't junk. It's really real life stuff.
Sure is.
But the more you remember it, you can relate to it, the better off you're gonna be. Okay, sorry guys, I'm always talking too much, aren't I? I hope I said that in my survey. She talks too much.
Now, if you want to see when people are more critical, go to Rate My Professor.
Rate My Professor?
Yeah. But you're people like you there.
Oh, they do?
Yeah. But you're gonna get harsher criticism there because it's to warn students about things. Like for them
Did
to
you
choose
warn
their
them about
professor.
me?
No, I haven't done anything on Rate My Professor except choose my professors.
Oh. You gotta warn them about me.
You doing all right? You doing okay?
Good?
Hey, are you really sure about your last one, man?
Mm-hmm.
Was that a 6 at the beginning and not a 0? Oh, that is a 6. That's why. You have the same as me, and I've been tripping on that the whole class.
Okay.
So I thought you had a 0 with a line through it, like not all real numbers 200.
Does each of them say that?
Um,
On your own page of paper? I don't know.
yeah, I think it just says for like.
What is this? Oh, I stapled my notes to it accidentally. I guess she's getting lyrics to Chicka Boom, Don't You Just Love It by Daddy Dewdrop. I had no idea. I was saying with the Texas Instruments, you get better competition if it's less oligarchy.
Okay. Here we go.
He's like, who you calling a Ramon?
Huh?
He's like, who you calling a Ramon? I'm like, easy, Joey.
Uh-huh.